Kenji will be presenting Think Aloud strategies. At this current time, can I request all of y'all to turn off your laptops? Sorry. Phones away. Thank you very much. The learning targets is by the end of this session, teachers will understand what a Think Aloud is and why it works. Experience Think Aloud as learners, what learners learn from there. Practice Think Aloud using universal science tasks and plan one immediate classroom application. So if you see papers and pens on your table, you will be doing an activity with this. Participation agreement, be all in your colleagues and the content, share your ideas and perspective, prepare for cold calling. I think Mr. Kenji will do that. Cold call people, huh?
Okay, so what is the question? It's gonna be teamwork, right?
Teamwork.
Okay.
Silently look at this graph and describe what it is showing. Yeah? Yes. Yes, I heard. The biology teachers are saying yes, chemistry teachers are saying, oh yes, we did this. Physics teachers are all over the place, they got it. Of course, CTE are technology people, they know what it is. Chemistry, yeah, chemistry teacher. Oh, yeah.
And then
Can I give you 1 minute? Because all of you are too good to be true, they already got it. Yeah, they're going into depth. They're going into depth. Yeah? Are we good? Okay, let's start this.
speed of reaction.
Okay, so where are we? Now turn and talk, which you all did a little bit. But turn and talk, what did you notice first? What assumptions did you make? What background knowledge did you rely on? And what questions popped into your mind when you look at this? So write it down on a piece of paper when you're working with the group. What did you notice first? Yeah.
That it was a graph, is the reaction and temperature.
The graph.
Graph, the variables,
The what?
how do you program the graphics? Variables?
Very
And then, is this one? That's yours. Just.
It's changing first. The graph and variables.
That is second.
Okay, next.
And then show the optimal temperature.
Want me to click on
Timer.
the video every time?
I'm not doing it because it's
Okay,
too much.
yeah, I was
It's
about
too
to
much.
say.
It will take us away.
Okay, in chemistry, how do you say it's the rate or the speed of the reaction? Rate. So you calculate.
Wait.
Okay.
Do we need more? 1 minute? Are we done?
One more minute, please.
1 more minute.
It's not reaction.
But the chances you make it.
It's a correlation between two variables
In our kettle.
related to
No, yeah.
In chemistry.
No, it's the same. It's kettle, it's the division.
good temperature from the test tension. What background knowledge?
What background?
I
No, did you
don't know.
Biology.
Biology.
Or what questions, what else are we talking about, or which reaction?
What is it for?
What type of reaction? Or what is the enzyme, what type of reaction?
Best.
Yeah, right.
That was a good example to do that. Everyone talking to it.
Career
Nicole, and, because it was.
And there's also reaction.
We have all the answers.
Yes.
By the way, my chemistry was.
Let's see. Mr. Akinji, would you like to call on the question number one? What did you notice first?
Chemistry. Yeah, from the
Ms. Raza, would you like to share
Yes.
from your group that
Okay,
you
so
guys came up with?
the first idea, the first things that we noticed is that it is a graphic,
Very good.
the variables
Variance.
that we had, the optimal temperature,
Mhm.
and that it's talking about the reaction, because it says rate of reaction.
Excellent. Very good. Very good. Okay, what assumptions did you make?
Yeah. So, that we are talking.
Oh, you wanna
about-
continue?
I
Yeah,
know,
go ahead.
no.
Rita, go ahead.
Go ahead.
Okay,
Do this
so,
one too.
that we are talking about enzymes or
Catalyst.
catalysts.
Very good. Yeah, that's an assumptions you made. It doesn't say enzymes.
Yeah.
It says rate of reaction, but you can say catalyst or an enzyme that you made assumptions. Very good. Very good. And what background knowledge did you have? Did you rely on?
No. Alright.
Mr. Trey, would you like to share?
What background knowledge did you rely on?
Were you kinda on the same page with her? Yeah.
Oh, yeah.
Yes?
Not quite.
Or if you
I-
might wanna kinda share your thoughts and what kind of background knowledge did you use?
I've seen the sharp drop in,
Yeah.
in the curve there. So I'm thinking about the melting ice, rather
Okay.
than whatever is that, okay? I have background knowledge like her as a scientist, okay?
Sure, that's why
See-
you can have your own version.
Yeah, and I thinking about the beverage. Okay, we put ice in the water and so on, temperature melt down, then 60 degrees, stay.
Yeah.
The question I'm thinking about what else this could be applied to.
Okay. Yeah. Yeah. What questions popped into your mind when you looked at this?
Mr. Oz, would you like to share?
Actually, I didn't, nothing popped up about
I think
because I
I
never
can ask
think.
this question.
Okay.
He was very clear on it because
But
he
I
has got
can,
this. Yeah, well,
Well,
from a
take
student's
it in
perspective.
terms of student
yeah, I
perspective.
can
What
understand.
equation are we can use, for example, in the chemistry, which equation is the best to use, for example?
What they might think of, you know.
Yeah,
I need
what equation do you use?
math before, what is that graph? So
Yeah,
Yeah,
you
so,
should- you
Okay.
should- Sorry,
That's your
yes, you have to teach us chemistry because not math, you know?
yeah, they will kind of struggle with the graph interpretation,
Yes.
right?
Yeah.
So-
graphic interpretation,
Yeah.
yes. And why is it a bell-shaped curve, you know, does it make sense to you? Usually they see a linear graph.
Yep.
Excellent, very good. Okay,
Yes.
let's do this. The model think aloud method. What are we gonna study today is a think aloud method. So the model think aloud method, it focuses on providing students with direct instructions that aims to support students with the tools and strategies needed to address and master learning tasks independently. Okay? So this think aloud method, it's a teacher who does this think aloud. What it does, it supports students to master the concept. During think aloud, teachers explicitly model by voicing over what they're thinking. So what teachers are doing, they are showing the thinking process. What are they thinking when they are solving a problem? They work through the procedures and cognitive steps for the selected learning task as students observe. So basically, the model think aloud method is a teacher is solving something, but it's thinking aloud and letting students to think at the same time. Okay, and there is a big, okay, so I'm gonna talk about this and we're gonna talk about what is the difference between modeling and think aloud process. Okay, keep these two things together. What is the difference? We tell teachers no, we need to model. Okay, for students to understand, we need to model. So what is the difference between modeling something and think aloud process? Okay, components of Think Aloud. Because when I was looking through this, I said, okay, what is the difference between modeling and Think Aloud? Because we have been told many times, model this, teachers model and students practice that, right? So we're gonna learn little different things here. So in the first part, these are the components. There are 4 components of Think Aloud. First is active listening. Students know what to listen for, okay? They are guided. The teacher tells you what to listen for. Students are given a clear listening, note-taking task during the Think Aloud that fosters active listening and supports students' processing of thinking steps and applied strategies. So as a teacher, you're gonna say, hey students, now what you're gonna do, you're gonna make a box. Anyway, you're gonna graph. Like if I'm taking this, okay, I'm gonna say, hey students, we're gonna do a graph today, okay? And I'm gonna tell them what they're expected to do at this time. This is the first step. They're gonna listen, students are gonna listen, and they know exactly what the teachers are asking them to do. The next step is visible thinking steps. The teacher-led Think Aloud is driven by replicable thinking steps. Okay, teacher will ask students to thinking steps. Can apply on a variety of questions aligned to the target of TEAC skills being addressed. So these steps are not only allowed to do one activity, so that's the reason we have science and CTE and everyone, chemistry, biology, physics, all together here. Okay, these skills can be applied on any TEACs, on anything that you're doing. In this, the teacher said, create an anchor chart that includes the thinking steps for future reference, okay? So they're making a little guide for themselves, the students. The next step is narrate your thinking, okay? You're gonna be narrating your thinking, it should be authentic thinking. The teacher demonstrates how to apply thinking steps and strategies to specific tasks aligned to the targeted learning gap or skill, okay? So this is all what teachers are doing, the red part is the students are doing, okay? So teacher is gonna talk aloud, think aloud, giving the strategies, thinking steps, what the students should be doing. Students can see, they can see it, and they can hear it. What the thinking steps aloud and sound like in action. The last is debrief and stamping. Students are given the opportunity, after this, all these things that you have done with the students, now you have to give the chance to the student, an opportunity for the students to show what they have done, what they have learned. Students are given the opportunity to debrief the key takes away from the Think Aloud and reflect on the new thinking steps they want to focus on during practice, future practice. What did I do in my model is the thing they will be thinking about. What are the key things to remember when you're doing the same task? This is very important for especially for STAR testing students, right? We say that, okay, underline this. What are you supposed to do? Think about it in math, biology, all these subjects, right? So that's what the debrief is usually where the students are doing it. Okay, this is what I wanted to show you. It's a wonderful video. It's a very short video, 1 minute or 2 minutes. It's gonna show you the difference between Think Aloud versus modeling, okay? I'm gonna play this video here. Please pay attention because this is the most important part of it.
Think Aloud is different than a model. And I think elementary knocks my socks off with this. For a secondary teacher, I didn't even know about these.
Sorry for that.
It wasn't until I was coaching I really appreciated the power of a Think Aloud. Let me explain the difference between a Think Aloud and a model. Because for some of us, we might be thinking we're doing a Think Aloud, but you're doing a model. It's not enough. If I was teaching a kid how to shoot a free throw, I could just model it. Okay, you're a forward. Woo, we gotta work on this. Let me show you. Okay, so you get to the free throw line, and this is a free throw. Okay, so this is what you're gonna do. Got it? Okay, I'm modeling it. You getting it? Got it? Good. Your turn. Okay, nothing's really gonna change about his thinking or his ability to do it. We switch that. This is a Think Aloud. Okay, so we're gonna learn how to shoot a free throw. So the first first thing I do when I come to the line is I look down. I'm right-handed, my right foot's slightly in front of my left. It's not really obvious, but that is what's happening. Here's definitely what's not obvious. I'm leaning forward. You can't see that. Let me tell you, I'm leaning forward. I'm on the balls of my feet, I'm leaning forward. Now, let me tell you where I'm looking, because you can't tell. No, I'm not looking at the rim. You look at the rim, and you're gonna hit the rim. You don't look at the rim. You look up and over behind the rim. That's where I'm looking. All right? So I'm leaning forward. My knees are flexed. I'm looking up and over behind the rim. Now I'm just hold the ball. You don't need to spin it. You don't need to do it. Just hold the ball. All right? Hold the ball. I'm looking up and over the rim. I'm looking up and over the rim. I'm leaning forward. Now here's what I'm saying to myself. I'm thinking up, 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 snap. Up, 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 snap. Up, 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 snap. That's what I'm doing. Up, 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 snap. Okay, now I want you to do this. I want you to talk me through what you're thinking as you do it. That's a think aloud. Just doing one, just showing them how to put two sentences together, how to insert a transition. How did you know which transition? How did you know we needed a transition? How did you get there? All this buzz about growth mindset, we gotta replace their thoughts with the thoughts of the expert.
Okay, very short, sweet video, but I think it teaches a lot. Modeling is just copycat.
Copy, yeah.
When I was looking at it, I said, hey, copycat. Okay, are you using your thinking power? No. No. You're just copycat. You're just copying exactly what others are doing. But think aloud is a technique and a strategy. I think we all need to learn that strategy. That you need to make yourself think and the students think, and you need to speak loudly so the students can think and get into your mind and see what it's supposed to look like. Okay? So in modeling, you show what to do. You're just showing. In think aloud, you show how to think. Okay? If we just go with this, students not have mastered the concept. When you make students to think, that is the time when they will be able to master the concept and apply these skills in the later questions. Focus on the product. What should my final product look like? This focuses on the process. How should I be able to solve this answer? What am I supposed to look at it? What variables are out there? What do I need to do? Okay? Things like that. Often polished. It's given perfect answer here. This is not polished. This is imperfect. Okay? Purposely is done so that you start thinking what should be the right answer be. We don't want to give all the perfect answers to our students. They don't think. They are just absorbing, they're just copying, okay? The answer to this is S equal to VAT plus RVT squared. Just don't make them just say that. You give them practice problems on that, right? So that's what we are talking about. Can be silent, okay? You're just showing modeling how to do it. This should be verbal and reasoning. Why are you doing it? What are you doing it? You're speaking aloud. Yeah? Okay, modeling and thinking aloud trends. Why are we doing this? This is the main question, right? So throughout the districts, what they saw that, well, first trend is that this was frequently missed opportunity to address gaps in students' learning. Okay, students' gap misconceptions are not being addressed prior to guided or independent practice. Okay. Modeling think aloud instruction strategy is inconsistent. Okay. The second reason, thinking steps are unclear and not explicitly voiced. So when the teachers are showing that thinking steps, some of them are just doing it. And I tell you right now, when I was teaching math also, sometimes AP and Environmental Science, a lot of math, you just show it to them, okay? Thinking steps have to be given to them so that they understand what is in my mind, how am I solving this problem? And in chemistry also, how to balance equations, to all that. That's required thinking steps. Causing the thing aloud to feel unfocused and only applicable to the question being modeled. We want them to start thinking these things. The third one is debrief is missing. An opportunity given to the students is missing. The last step, remember that, was teachers will give an opportunity to students to debrief what they have learned. Okay. This is an example of math, okay, of the thing aloud process.
Not just focusing on the math, but also focusing on my thinking. So I want you to think aloud of how you should tackle these problems on not only your test next week, but on your rigorous AP test next year. you'll look into my thinking for today. So the question is asking me to evaluate each of the limits, and I see that I have 3 different limits. So before I even get started on these limits, I want to just focus on the function given. So I'm asking myself, what function is given? Because I know I've seen so many different function types before. Looking at this, I know I have a polynomial in the numerator, a polynomial in the denominator, so this has to be a rational function. Okay, part A is asking me at the limit of f of x as x approaches 3. So I know that 3 is a finite value, meaning it's not infinity or negative infinity, it's an actual number that I can reach. So I'm going to write down finite value because that's going to activate my thinking. So what do I know about finite values for rational functions? I know that I could
See, like, she's thinking, right?
Yes.
She's
I'm
just,
going to say that.
what I know about this, and
Yeah.
you
Thinking
know,
alike.
like, yeah. So it's just kind of catch to some of the moments, guys. I know it's kind of long video, but
have undefined values because I have a vertical asymptote or a hole, or I could have a continuous point for all my other defined values. So thinking about these 3 things, looking at this function, this isn't giving me much useful information. So I know that if I want to identify those undefined values, I should start by factoring this. I don't really remember much about how you find limits at holes, so I'm going to create a visual for myself to think about what does my graph look like at a hole. So I know I have a rational function. I'm just sketching any rational function with a hole. If I had a hole at this value of 3, and I was to look at my limit from the left and the right, I know that for a hole, it always approaches whatever this y value here is. Interesting. So I know it's going to be the same for both sides, and I know that it approaches this y value. Thinking back to unit 7, I know exactly how to find a y value of a hole by just substituting in. I could substitute into this factored form or the simplified form. But I know if I substitute into just the factored form, my answer is always going to be undefined. So I have to substitute into the simplified form so that my denominator doesn't end up being 0.
anything else you caught, like you want to share before?
It's like I do and we do with the students by asking the same questions, same steps, and we are giving them to do by themselves. It's like we are practicing this and
Exactly. Yeah, and if you look at it, the students are taking notes, so they know exactly what to do. The teacher explicitly showed them what to do. And when you're looking at the choices, thinking process, she's showing I can do this, I can factorize, I can simplify, giving all the options for the students to start thinking in those terms. We know our subject very well. We know exactly what to do, right? Students, they are like, they don't have much idea. So the teacher is providing all the options there.
By only like showing, okay, if I do this, I know this is not gonna
Yeah,
work.
zero,
And she was gonna
yeah.
keep changing it,
Yeah.
and that way kind of close
Make
the
them
gap.
to think
Yep.
which one would be the best choice.
And it kind of fits in the plan for error too. So
Yes, yes, right.
You have 30 seconds to do the following with your partner. One quick note check, any clarifying questions you have, and the bulk of your partner work should be focused on these two parts. What were the questions I asked myself, and what were the thinking steps? Please share with your partner and jot those down. You have 1 minute, go. Hands down, just sharing some of the thinking steps or questions. Please add to your notes as your as your peers share.
What question she asked was, what function is she given?
Another thinking step was you have to think about whether it was a whole vertical asymptote or a continuous point.
Perfect.
Another question that you asked was, what does the graph look like as a whole?
Great. Why did I annotate finite value here and whole here?
was, which,
Step was it?
we had like 4,
Components.
yeah, components. Which one was it?
Debris.
The brief, right?
Very good.
Okay,
Yeah, you
perfect.
did it. Okay, so now what you'll be doing with your partner, discuss your responses to the following question from the model you observed. Oh, we did it, right? Okay, where did you see evidence of the success points during each teacher's think aloud, active listening, thinking steps, authentic thinking, and think aloud debrief?
Yeah, we're kind of,
Yeah,
yeah, in a way.
we said it.
If you wanna add on it, please feel free.
Anyone wants to add anything on it, because we kind of did it. Mistakenly stopped and asked you questions. Active listening when they were sharing the thoughts, right? Debrief, as Ms. Bass said, the last.
That was a cold call, I don't know if you noticed, yeah, so
Yeah.
1 or 2 times.
Yeah.
Classroom discussion in a way, so.
Mr. Akinci, did you go fishing last break?
Don't change the topic.
Okay. You see, give instead of fish or show them how to fish.
Yes, yeah, I like the fishing, by the way.
Show them how to fish.
Yeah,
They can fish
that's a good
by
example.
by the edge, by the bank of the river or on the boat in
Exactly.
the water. And
This
so
is
on.
the
It's any situation they can,
subject.
they can
Yes,
do.
this is embedded into the discussion, very good, yes, sir.
Where did you go fishing, sir?
Well, yeah, just have you get rest a little bit, so, I went to the Mayor's Park, but there's a website on the Texas Wildlife, if you just, type, trout stocking and the ponds near Houston, around Houston, they're gonna give you the numbers and dates, which day they stock the, trouts. So mainly there are just the rainbow trouts, and you can just go with your kids and the day after or week after.
So my question, good question, right?
Yes.
Very good.
Mr.
Yes.
Ram, did you join Mr. Akinci?
If anyone's interested, I'll show you later, so.
Okay, so these are success points out here, active listening. Ms. Sayed said that active listening, while I'm working through this problem, I want you to focus on this box. You needed to list down questions that I'm asking myself and any thinking steps that I'm taking, whether it is an annotation, a sketch, any notes or something that I say that I do not necessarily write down. Okay. For thinking step, she said, so before I even get started on these limits, I wanna just focus on the function given, step number 1. Authentic thinking was, so I'm asking myself what function is given. Because I know I have seen so many different types this year. This is typical for students, okay? They have seen so many things. Look at this now, look at this. I know I have a polynomial in the numerator and a polynomial in the denominator. So this has to be a rational number. So she's talking to herself and making people realize that what is a rational number. Think aloud and debrief. You have 30 seconds, 1 quick note, any clarifying questions you have, and the bulk of your partners who work should be focused on these 2 parts. What were the questions I asked myself and what the thinking steps? Please share with your partner and jot those down. So this was the debrief part also. Okay, plan before we practice. So what are we planning now? You have 12 minutes to plan your entire script, okay? Active listening, thinking step, think aloud, authentic thinking. So you're gonna plan tasks, use the planning document, I will share it with y'all, and script the following 3 things. Thinking step, think aloud, authentic thinking. What are we practicing after we plan? In 8 minutes, we will be delivering the entire script 1 time to the group using your document camp. Well, no, we're not using it. Okay, this is an exemplar. I have given it to you. It's just the same thing that is there. The copy, the sheet that I'll share it with you will have this exemplar. Okay, what are you modeling? The same questions that we talked about it. and then you will be planning out your own thing. Thank you.
One each or
Um,
is it, how do you want to?
I think one per person because the exemplar is there. The first page tells you the steps and what it looks like, okay? So draft your thinking steps. It says thinking steps are sequential and lead to exemplary responses. Thinking steps are scaffold and target to a specific skill, connect standards. Thinking steps are transferable, replicable. Students can use them with similar tics based on this future, in the future. Thinking steps address potential or identify misconceptions. Thinking steps model the thinking, not just the procedure. Next is test drive the thinking steps to meet exemplar. Ms. Ward, can you read the second passage, second box for me? What is the test drive and thinking steps to meet exemplar?
Test drive?
Practice applying the thinking steps to the example you are using to model in order to ensure flow, clarity, and effectiveness. Revise student thinking to ensure students can reach the example.
Thank you very much. Then narrate your thinking, Ms. Renza, can you read that? Next page, first box.
The script what you will say to model thinking skills considered. Explicitly stepping into the model by changing your tone and cadence from your teacher voice to your think aloud voice. Voicing over what you are thinking aloud to yourself for students to observe. Using I statements to make it clear that you are doing the thinking. The first thing I do when I am solving this problem is modeling how to activate one's own content knowledge and skills that have been learned in previous lessons. Explicitly connecting procedural steps to the conceptual understanding behind those steps. The next step is to regroup because I know that 10 ones make one group of 10.
Thank you. Mr. Kartash, can you read the last box? Debriefing,
Which one?
the last box on the second page.
Second page.
Debrief and stand.
Students are given the opportunity to debrief their key takeaways from a think aloud and reflect on the new thinking steps they want to focus on during future practice. Example, what did I do in my model? What are the key things to remember when we are doing the same task?
Thank you very much. And then finally, after that, you have an example of everything right here. This is what's being shown. As I read through this, when you're looking at it, draft your thinking steps are sequential, identify the independent and dependent variables. I think Ms. Renza talked about it, there are variables out there, if you remember that. Describe the trend as temperature increases. Identify the optimum temperature. Explain what happens at the optimum point. Connect the patterns to the enzyme. As we said that we had to assume enzyme or catalyst activity. Now, looking at framing your model, again with this, an example is given to you already, okay? What are you doing here? As I analyze this graph, I want you to pay close attention to the question I ask myself and how I decide what the data means. Now, this is what you're talking to your students when you're talking about it. While I'm thinking aloud, take notes on one question I ask and one conclusion I begin to form. After I finish, you turn and talk with your partner about the thinking steps you notice, okay? Then narrate your thinking, okay? So with your partner, with your group, if you're working in a group, with your group or with your partner, go over this, and then I'll give you a couple of minutes, then you're gonna do an activity, and you're gonna write your answers here. So that way, I'm gonna give you a question, then you are gonna start thinking yourselves. Or I can create one for them too.
No, you don't have to. One for each, right? Enough? You have enough?
Yeah, okay. I think we should split this group into two, full would be best.
I can.
Yeah, if we can have split this group because. Thank you, Ms. Hamza. Thank you, Ms. Hamza.
Is it just 1 year?
But
You're doing very good with time. So what Mr. Akenji is passing out, he's passing out a question for you to do it. There is a chemistry question and there is a biology question. I'm sorry, CT. I think you can do biology on its easy. Yeah.
Choose the one you like.
And also that you're just more than solving, your thinking steps you're looking at.
Students how to think to solve that. So it's not just showing, it's that so the example here, for example, is like, they give us the
I'm gonna take it to Ms. Renza. No, I need Ms. Renza explaining very well.
I always check the variables that I always check what is it talking about, so identify the same process that we do it is when we have to explain or teach to our.
Yes, please.
How long?
Okay, so basically what I'm looking at
10 minutes,
is
give it
how
10
we're
minutes.
saying, okay, well, I see the rate of their reaction and I see the optimal rate and I want to, my first thought is where do they connect? So what is this point? So if I'm looking at the rate of their reaction and then the optimal rate, at what point does it intersect with each other to make,
Yeah, the optimal.
right?
So, the idea is that we can create like
başka ne yazayım?
so what do you think
I
they
don't
need to
know.
be
Falan
first,
diyorsun
what's
işte.
here, what's here?
Aynısını
Why are
yapacak
they,
bir şey.
Why is
The
it important?
one of the
the
parents
first graph, the thing is, the second one, so we are
third
going
row
to create
is
and
like
analyze these graphs, we have to create.
dominant
And I want you to
and
make
the other
while I'm taking, explain this, just take notes.
recessive.
And after I finish, I will ask you, or it will be your turn. This is the Franger model, so explain or detail what do they need to do while you're doing. The next one is, yeah, mine is making a set. And the last one.
Alright, the next step is to identify the genotypes. So they've already given us the genotypes. It says one guinea pig is SS and one is little s. So using my key, I can determine the actual genotypes. So big S, little s means that I'm what? Heterozygous or homozygous?
Hetero.
H2O, right? That's the root symbol for water. H2O. Now I have 10 grams of hydrogen. If H is 10, then oxygen should be 5. Correct?